Everyone, this is Meghana Nallamilli, 20MA20033. As we can see, this is the virtual Arduino board, and this is the virtual humidity and temperature sensor. I have modified the source code to meet the given requirements. If the measured temperature is less than or equal to 15 degrees Celsius, or it is greater than or equal to 28 degrees Celsius, and the humidity is less than 25%, then the LED would blink for a time period of 1000 milliseconds or 1 second. And if the humidity is greater than 60%, then it would blink for 0.5 seconds. In every other case, the LED would be off. So let's see a demonstration of the same. Let's run the simulation. Here the humidity is greater than 60% and the temperature is greater than 28 degrees Celsius. So it should blink for 0.5 seconds and stop. And again. Now if we try changing the temperature to less than 28 degrees Celsius, then the LED would go off. So the temperature is less than 15 degrees Celsius and the humidity is greater than 60%, and the LED is blinking with the same frequency as before. Now let's try changing the humidity. So the humidity is less than 25% and the temperature is also less than 15 degrees Celsius. The LED would blink for 1 second and stop, and so on. If we try changing the temperature to something between 15 and 28, then the LED would go off. And if we increase the temperature to more than 28, then it would go on for 1 second and go off again. The second activity, which is the generation of the square wave, first I connected the D channel to the 13th input pin, which is connected to the LED. Let's take a look at the source code. The red, green and blue pins are redundant in this case. So this is the code I've written for it to go on for 0.5 seconds, then off for 1 second, then on for 0.25 seconds, and off for 0.5 seconds, then on for 2 seconds again, and off for 4 seconds. So there are 3 parts to this waveform. So let's run the simulation. And let's look at the digital oscilloscope readings. So this is how I've configured it. 1 millivolt is the high value, and I've positioned it in such a way that we can see it clearly, and 200 milliseconds on the x-axis. I have put it on DC as our output is in DC, discrete values are not analog. As we can see, this waveform is continuously repeating as was required. So yeah, I think that's about it. Thank you so much for watching.